Hi guys, so I hope you all are doing well. So today our topic is basic proportionality theorem, right? Now basic proportionality theorem, okay, seems a little complicated to many. So today we will try and simplify this, okay? So this is very important from exam perspective because there will be so many questions based on this particular theorem, okay? So I'm soon going to get the converse of this theorem too, but let me explain you this at first, okay? So this is the figure, and what they say is that in a triangle, say in a triangle we have AB, BC and AC. These are the three line segments that go to make triangle ABC, right? So they are saying that, say supposing DE is the line, okay, which cuts AB and AC at D and E respectively, and DE is made deliberately parallel to BC. Now this side, okay, is the third side, and DE is made parallel to this third side, which means what? That the two other sides will be cut, okay, interestingly into two same ratios. AD upon DB then will be equal to AE upon EC. Let me repeat. If DE was to be parallel to one side of a triangle, then the other two sides automatically gets cut, okay, in a ratio that is similar to each other. See, it states that in a triangle, if a line is drawn parallel to one side of a triangle, say DE is made parallel to BC to intersect the other two sides in distinct points, in different points, it divides the other two sides in the same ratio, correct? So we are out to prove, okay, that the AD upon DB is equal to AE upon EC provided DE is parallel to BC, one of the sides of the triangle. Then what happens to the other two sides? They are cut in a manner that their ratio, okay, say AD upon DB and AE upon EC will be same. If this is 2 and this is 5 in ratio, and then we'll find that even AE upon EC will be 2:5. If this were to be 1:1, this also will be 1:1, okay, and so far, okay, and so forth. Now we need to, okay, do certain constructions which I have shown in broken lines. DE was made, so this doesn't have to be in construction. So BE is drawn, okay. So also CD is also joined, and two altitudes have been dropped. EF and DG have been dropped on the two sides, okay, respectively, correct? So EF is perpendicular to AD and DG is perpendicular to AE. Okay, EF is perpendicular to AD and DG is perpendicular to AE. Alright, now we need to prove this part of it. Okay, so how do we go about it? Let me explain you. Now I have made a replica of the same diagram here so that it is easier to refer to it while we are proving it, right? So here to start with, we know that area of a triangle is calculated by half into base into height, isn't it? You must have done this formula. Now, we pick up triangle ADE and triangle DBE. Remember ADE and DBE. Why so? Because first we are heading towards AD upon DB, which means AD is the, okay, hero over here, and below the in denominator we have DB is the other hero here. So we can't avoid them. so they can't be ignored. So we have to pick up AD. So AD has, okay, an altitude EF, isn't it? And DB has an altitude EF as well. Now, some must be wondering how can, okay, we pick up EF to be an altitude for BD. Well, let me explain you that we could have dropped, okay, an altitude here on BE. In that case, we would then have to take BE as the base. But here we want, okay, an altitude over BD. This will become clear. Let me explain you here. So in triangle ADE, half into AD into EF will fetch you the area. Area of triangle ADE is equal to half into base into height. Correct? What about DBE? We have the base. We want the base. We want DB to be present there. Alright? So, if DB were to be present, we have to take something that blends with this base, EF. And since this is an, okay, obtuse angle triangle, so this is the vertex of triangle DBE. So from here, when BD is produced, we try and make an altitude on BD produced so that, okay, we get finally the height of triangle BD. Alright? Correct? Got it? You can pause the video also to understand this better. So in an obtuse angle triangle, okay, most of the cases we find that, okay, the altitude lies outside the, okay, internal region of the triangle. Correct? So likewise we have AF outside the area of BDE. Okay? So now we find out the area of DBE, which is equal to half into now DB upon EF, base into height. Next, we try and find out the ratio of ADE and DBE area wise, right? So we copy this, we copy paste here, and what do we find? That half gets cut, EF gets cut because they are same, okay? We are left with AD upon DB. So 50% of our battle is over, guys, because we have found this, okay? Isn't that a good thing? Now let's go ahead to try and find out this also. And we did exactly the same. We picked up again ADE, okay? Because AE happens to be a part of ADE. Now we want EC also, isn't it? We want EC also, which means this must be, okay? So this, okay, this triangle, okay, will be taken into consideration. So again, this is an obtuse angle triangle, correct? This one. So when CE is produced to G, we are able to get the height of this triangle. Am I right? So this triangle ECD has an altitude DG. Alright. When we have EC, okay, as the base. So half into AE into DG was for AD, and half into EC multiplied by DG is the area of ECD triangle. Alright. So when we once again, like how we had done there, we bring them as ratios. What do we get? We get half gets cut, DG gets cut, AE upon EC. So we have found this, but are they equal? There is a big question mark, okay? So in order to find, okay, the equality of these two, we have to do a certain tweak, okay? And that is very, very possible because we can very clearly see that this triangle and this triangle are sitting on DE as a common base and they are stretching between two parallel lines, which you have done in lower classes, guys. So if any two triangles sit on the same base and stretch between the same parallel lines, their area is same. Okay, so in that case we know that they are clones of each other, they are duplicate of each other, which means can we not just cut this and write ECD there, or can we not? Okay, right. Okay, the same thing, okay, again for this also. Why so? Because ADE is after all the same triangle we are talking about, but DBE is also, okay, equal to ECD. Why? Because, okay, they are sitting or between the same parallels and on the same, okay, base. So which means area of ECD is also equal to DBE. So if we have this same as this, their right hand side also must be equal. Am I right? Some, okay, of the reasons I have laid out here very clearly for you to understand that now we know that area ADBE is equal to ECD. Okay, this is from equation 1 and equation 2. We get this, they are equal to each other because triangles on the same base, okay, which is DE, and between the same parallels, okay, that is BC parallel to DE, we know that these two triangles are equal. So if they are equal, which means triangle, area of triangle ADE over triangle, okay, area of triangle DBE will be equal to area of triangle ADE, okay, over area triangle ECD. They will be equal to each other because this one is equal to this. As a result, RHS will also be equal, which means AD upon DB will be equal to AE upon EC. Okay, so understood. So next I am bringing the converse of basic proportionality theorem for your understanding. Okay guys, so have a great day, enjoy yourself, but study hard. Okay, bye bye. Thank you so much for watching.